Alright, here is the Unit 5 review. We're going to start with proof. Proof is going to be quite a few questions on this test. Questions 1, 2, 5, and 13 all deal with this proof. So if you know this proof inside and out and understand it, you will get those questions right. Let's go ahead and start by drawing the picture. Let me do that in a different color. This green line right here from the vertex, which is the 90-degree vertice, perpendicular to the other side, that is called your altitude. We're going to label that H. The green line is your altitude. It's perpendicular from one side and goes to the opposite vertex. I'm going to label it like the picture is. C, A, B. The whole hypotenuse is C. This side is X, that side's Y. So after you get the altitude, which is huge in this proof, you need the altitude, you're going to have three new triangles. You're going to have the large one, the medium one, we'll call this one the medium one, and then this one the small one. I'm going to redraw all these to make it easier to look at. In this proof, we want to prove that these three triangles are similar. First of all, they all have a right angle. Let's name this D. They all have a right angle. So all I need to do is prove one other angle is congruent in each, and then I have angle-angle similarity. This would be D, B, C. This would be D, A, B. Alright, so in these triangles, if you look at the large triangle, angle C is right here. If you look at the medium triangle, the second triangle, this one, angle C is right there. So angle C in the large triangle is the same exact angle C that's in the smaller triangle. So angle C is congruent to angle C. Reflexive property, which makes these two triangles similar, angle-angle similarity. Then in the large triangle, you have angle A. In the small triangle, you have angle A. Angle A in the big triangle did not change from angle A in the small triangle. Therefore, these two triangles, the largest one and the smallest one, are similar. Angle-angle similarity. And with the transitive property, since the large one is similar to this one, and the large one is similar to the small one, since this one is similar to both of these have to be similar to each other. And now we're going to write a ratio of the sides. Label the sides. This was A.
See if I can find a different color. This was A. BA is A. BC is B. DB is H. And CA is C. CB, that's B. CD. CD is X. And BD is H. This is H. DA is Y. I'm going to set up a ratio of the sides, but I'm not going to use H. H is inside the triangle. I don't care about inside the triangle. I'm trying to prove A squared plus B squared equals C squared, which is all the outside of the triangles. So here goes. Setting up my ratios of sides, I have within these first two triangles The only thing they have in common is the b's. So you have b, this b over c equals, corresponding to BC would be CD, so it would be x over, corresponding to C would be the hypotenuse, which is B. That set up the ratio of my first two triangles. Now I'm going to do the second two that I proved were similar. The only thing they have in common is the A. So you have A over C equals, corresponding to A would be Y, corresponding to C would be A. Now that I have this, which comes from the fact that these are similar triangles, I am then going to use the cross product and cross multiply these. So b times b is b squared, c times x, cx. A times a is a squared, c times y, cy. Now I'm going to add these two together so that you get a squared plus b squared. Let me make more room. I'll go back up here. You get a squared plus b squared equals cy plus b squared. That's the addition postulate of equality. The addition property of equality. If you add one thing to one side, you have to add the same exact thing to the other side. Then I'm going to change it. A squared plus b squared equals cy plus cx. I know that b squared equals cx. So then substitution, anywhere I see a b squared, I can put a cx. Now I'm going to factor a squared plus b squared equals c times y plus x. They both have a c, so I can factor out a c. Now y plus x. If I take y and I add x to it, you get c, which gives me a squared plus b squared equals c times c. C times c, a squared plus b squared equals c squared. From this step to that step, segment addition postulate. So let's just go over this real quick. You have your picture. You need the altitude, which is the perpendicular height of the hypotenuse. That divides it into three triangles that you will prove is similar by angle-angle similarity. From there, you set up your ratio of sides, which comes from the definition of similar triangles. Sides are proportional. You want to set your sides up in such a way that you get a squared and b squared after you multiply them out. Make sure your b's, one's in the numerator, one's in the denominator. A's, one's in the numerator, one's in the denominator. That gives you a squared and b squared. Then you need to pair your c up with each of the pieces of its line. Notice how it was cx and cy. Cx and cy. C was paired with each of the pieces so that after I cross multiplied and then used the addition property of equality, I was able to get, after substitution, cy plus cx. They both have a c. C can be factored out. Y plus x, this is why c had to be paired with both y and x. So when you factor it out, you get y plus x, which is c. C times c, c squared. So you got a segment addition postulate, you got substitution, you got the addition property of equality, you got the cross product property, you got proportions set up from the definition of similar triangles. The similar triangles come from angle-angle similarity. The triangles are created by putting the altitude, the perpendicular height of that right triangle. Alright, that's questions 1, 2, and 5. All of that, something from for each question will come from that proof. Number 3, in triangle ABC, B is 90 degrees. Alright, so I know I have a right triangle, and I know B is my right angle. If the sine of A is 7 over 16, so it doesn't matter where A is. The sine of A equals 7 over 16. What is the cosine of C? C is the other angle. The sine of one angle is equal to the cosine of the other angle. So your answer, 7 over 16. The sine of one angle is equal to the cosine of the other one. So sine of A is 7 over 16. Cosine of C is 7 over 16. The hypotenuse of a right triangle, XYZ, is 28. So I have a right triangle. A hypotenuse is 28. Angle A is 60 degrees. Doesn't matter where A is. Could be here, could be there. Doesn't matter. That means this has to be 30, which makes this a 30, 60, 90. What is the approximate measure of the longest leg? Opposite the right angle is supposed to be 2x. So if you divide that by 2, x equals 14. That means across from the 30 is 14. Across from the 60 is x root 3, so it's 14 root 3, which is, I'll use a calculator you guys are supposed to use, because if it gives you the decimal, 14 times 3 radical is 24.25. So it's approximately 24.25. Again, typing that in the calculator is going to be 14 times. You have to type the number first, then take the square root of it. So that's the square root of 3. I'm still multiplying it by 14, so when I hit enter, there's the answer. Now, we can also use trig. If we have 60 degrees on the hypotenuse, this is, if I want the longer leg across from the longer angle is the longer leg. So across from the 60 will be bigger than across from the 30. So that means across from, there's opposite and hypotenuse. So you have sine. So sine of 60 degrees is going to equal opposite over hypotenuse. Variables in the numerator, that means you multiply the denominator. So you get 28 sine 60. Typing that in the calculator, you get 28 times 60 sine, enter, 24.248, which is the same thing that we got last time. So there's two ways to do it. If you need a review either way, rewind the video and watch it again, especially how to type it into the calculator. Number 6, in triangle ABC, everything in this test is going to be a right triangle. Let me just go ahead and write it. C is 90 degrees, so this is C. A and B, doesn't matter where they go. Write all the trig functions for both angles and show which ones are equal. So they want to know sine of A, cosine of A, tangent of A. And I am just going to write, actually let me label these. This will be little a, little b, little c. Then sine of B, cosine of B, tangent of B. So sine of A, sine is opposite, which is little a, over hypotenuse, which is C. Cosine is adjacent, which is little b, over hypotenuse, which is C. And tangent is opposite, which is little a, over adjacent, which is little b. Sine of B, B opposite big B is little b, hypotenuse is C. Cosine is adjacent, little a, over hypotenuse, little c. tangent is opposite little b over tangent over adjacent little a. They also wanted to know which ones are equal. Sine of one angle is equal to the cosine of the other one. So sine of A is equal to cosine of B. Sine or cosine of A is equal to sine of B. And your tangents, remember your tangents are not equal. Your tangents are reciprocals of each other. The fraction has just been flipped. Alright. 7. Word problem. At football training camp, there are 2 hills for players to run up. The smaller hill has an incline of 14.7 degrees, so this one is inclining less, 14.7 degrees, while the larger hill has an incline of 38.6 degrees. If Travis runs 1,000 feet up the smaller hill and Austin runs 1,000 feet up the larger hill, how much longer was the horizontal distance that Travis covered? Horizontal distance. I need the horizontal distance of each. They're both going to be the same trig function. This is the angle. That means this would be adjacent. And this would be your hypotenuse. Adjacent, hypotenuse. So they're both using cosine. Which means, for the smaller one, you have the cosine of 14.7 degrees is equal to adjacent over hypotenuse. For the larger one, you have the cosine of 38.6 degrees is equal to adjacent over hypotenuse. For both of these, your variable's in the numerator, so you're going to take your denominator and just multiply it out front. The smaller one, let's get an approximation, is going to give you 1,000 times 14.7 cosine, enter 967.27. 967.27. The next one, 1,000, the larger hill, times 38.6 cosine equals 781.52. 781.52. And it says how much longer is the horizontal distance. Well, these are the 2 horizontal distances, so you're just going to take 967.27 and subtract 781.52 to get a difference of 185.75 feet. That means although Austin ran up at a steeper incline, Travis ran farther by 185.75 feet. Alright, 11. The main beam to a circus tent is 75 feet tall and is supported by 120-foot wires that extends to the ground. So you have a pole, 75 feet. You have a wire, 120 feet. Oh, look at that. It creates a right triangle. To the nearest degree, what is the angle that is created from the wire and the ground? Wire and the ground is right there. Angle. So this is opposite. This is hypotenuse. That means we're using sine. But we're finding the angle. So we're not using sine. We're using the inverse of sine. 75, which is opposite 120 hypotenuse. So when you plug this in the calculator, you're doing 75 divided by 120 equals, then second sine. There's your answer, 38.68 degrees. So it's approximately 38.68 degrees. Right. 12. what can you conclude about the sine of angle AMN? AMN. AMN. Well, let's look at this. The sine of AMN, sine, opposite, 6 over 8. So 6 over 8 is the sine of AMN. And the sine of ABC, ABC, opposite would be 9, hypotenuse 12. So 9 over 12. What can you say about those two? Let's simplify and just check. This fraction simplifies to 3/4. This fraction simplifies to 3/4. What can you say about them? You can say they're equal. The ratio of sides. Trig is just a ratio of sides. Ratio is just a fraction. Simplify your fraction. There you go. If the triangles are similar, these two triangles are similar, their ratio of sides will be equal. That's dilation. This is similarities. That's the Unit 4 test. This smaller triangle is similar to the larger triangle, angle-angle similarity. They both have right angles. They both share angle A, reflexive property, angle-angle similarity. You can then say these two lines are parallel. These two angles are equal. So the ratio of sides, sine of M, opposite over hypotenuse, 6 over 8, is equal to the sine of B, 9 over 12. And we just showed that. They both simplify to 3/4. Alright, next one. Two ladders are placed at different locations on a light pole so that new light and cameras can be installed. The length of the longer ladder is twice the length of the smaller one. The shorter ladder is placed 2.5 feet away from the base pole, while the longer ladder is placed 5 feet away from the base of the pole. What is the distance between the two tops of the ladders? So here's a light pole. I'm assuming that's the longer ladder. We'll call that one the shorter ladder. All I know is that this ladder is 2 times that ladder. The shorter ladder is placed 2.5 feet away. 2.5. 5 feet away. So I need to find the hypotenuse. I need to find this length right here. I need this green. Right there. I need to know that length. Alright. Let's say this is 14. If that's 14, this side has to be 2 times 14, or 28. There's actually a missing number. You're actually given this number. I didn't give it to you in the review. I apologize. There it is. So now we need to find the length of that red line. How do you find the length of that? These are both right triangles, so we're going to use the Pythagorean theorem. For the smaller one, this is the hypotenuse, so this is your C. So 2.5 squared plus B squared equals 14 squared. And on this side, the larger one, you're going to have 5 squared plus B squared equals 28 squared. Now let's start squaring this stuff. 2.5 squared. This is 6.25 plus B squared equals 196. Subtract 6.25 and you get B squared equals 189.75. Get B by itself, you want to take the square root of it. So B is approximately 13.8. Now for the larger side, 5 squared is 25 plus B squared equals
28 squared, which is 784, minus 25, b squared equals 759. Take the square root of that. B is approximately 27.5. So how big is the red area? Well, you're going to take your 27.5. This is 27.5. This one is 13.8, and you're just going to subtract them. So 27.5 minus 13.8. So the two tops of the ladders are approximately 13.7 feet away, which is very big. Let's remember the review questions. This is a bad one because you're given this length. If you're given this length, then you know this one's twice as big. You just multiply this one by 2. You have that length. Now you have 2 out of the 3 sides of the of a right triangle. Pythagorean theorem. Subtract to get your answer. 15. An airline pilot is flying an airline pilot. Let's make my airplane. There's your airplane. Is flying at 10,000 feet. Sees the airport and angle of depression. Let's do this in a different color. Angle of depression. You find your horizontal line of sight. Angle of depression. He's looking at his airport. This is 12 degrees. To the nearest foot, how far is the pilot from the airport? So we need the horizontal distance. Right angle. This angle is not inside my triangle. I need to put it inside my triangle. How do you get it inside your triangle? Well, this is a 90-degree angle, so it's 90 minus 12, which is going to be 78 degrees. Now I'm trying to, that's opposite, that's adjacent, so it's the tangent of 78 degrees equals opposite over adjacent. This is in the denominator, multiplied out front. So 10,000 times tangent 78 equals, and this is going to be approximately, let's type it in, 10,000 times 78 tangent equals, he's approximately 47,046 feet from the airport. That is your Unit 5 review. Make sure you fill out the review if you're in my class. It's a grade. You're going to turn it in. That's not the Unit 5 review. I never did the back side of this. Alright, we're going back. We're going to keep going. This question 8, I didn't know it was on the back. Given xy is parallel. These lines are parallel. This is from last unit, guys. Prove that xm over mz equals yn over nz. Well, if those are parallel lines, corresponding angles are congruent. Corresponding angles are congruent in each triangle. Angle-angle similarity. Angle-angle similarity. This then gives you this triangle, xz over mz equals yz over nz, because they're proportional. Similar triangles are proportional. Then you're going to break up the numerator. Instead of saying xz, it's xm plus mz. xm plus mz over mz equals yn plus nz
over NZ. That's the segment addition postulate. Then just separate your fractions. XM over MZ plus MZ over MZ equals YN over NZ plus NZ over NZ. Anything divided by itself is 1, which gives you XM over MZ plus 1 equals YN over NZ plus 1. Subtract 1 from both sides, subtraction property of equality. XM over MZ equals YN over NZ, which is what we were trying to prove. Proof is done. Same exact proof from last unit, guys. You can even go to the Unit 4 review and look in more detail of that proof. Number 9. Triangle ABC is similar to AXY. ABC is similar to AXY. What is the ratio of cosine of A for both triangles? Cosine of A is right here. Cosine of A for both triangles. Cosine is adjacent over hypotenuse. So cosine of A, we'll do the small triangle first. Adjacent AX over hypotenuse AY. Cosine of A for the large triangle, adjacent AB over hypotenuse AC. Be careful with this one, because they'll try to trick you. They'll try to mix these up. They'll put AX over AC. They'll mix these up on you. So just pay attention. Now the last one. I know I went out of order. You'll get over it. Just watch the video, pay attention to what number you're on. As long as you know what's going on the review, you'll know what's going on the test. A communication tower is supported by a 175-foot wire tied to the top and staked into the ground. So here's my communication tower. 175-foot wire tied to the top, staked into the ground. Look at that, right triangle. If the angle of elevation, you're going up, elevation, formed by a wire to the ground is 67 degrees. Approximately how tall is the tower? Here's your angle. This is going to be opposite. This is going to be your hypotenuse. It's opposite your right angle. Opposite hypotenuse, that is sine. Sine 67 degrees equals x over 175. Multiply out front. 175 times the sine of 67 is going to be x, which is approximately 175 times 67 sine equals 161.1. 161.1. That is now your Unit 5 test. Good luck. Study. Watch this video at least 18 times, maybe 19, just to be sure. And you can finish off the second semester on a positive note.